Hi everyone, welcome to lesson 9. This is the first lesson in unit 2. So unit 1 covered lessons 1 through 8, and then now we're in unit 2. This will cover lessons 9 through 14. And this is where we really get into probably what you think of when you think of algebra. We're about to see more variables. In this lesson, we'll learn about collecting like terms. We'll use the distributive properties some more to simplify some expressions that have variables. And then starting with lesson 10, then we'll really get into solving equations and solving for x. So that's just a little kind of basic preview of where this is going. Okay, so let's start with just the title here, collect like terms. The phrase that I'm more used to using is combine like terms. So you'll probably hear me saying that more. They mean the exact same thing. It's just a matter of what words we're used to using. So collect like terms, combine like terms, those all mean the same thing. And then this simplify expressions, that's sort of the second half of this lesson, and it will still involve collecting or combining like terms, but that's when the distributive property will come back as well. All right, so what are like terms? So the word like in this case just means alike, meaning similar, kind of like they go together. So here's one sentence to understand like terms. So like terms have the same variables and the same exponents. So in this green box over here, here's some examples of like terms. Our first example, this is just a list, negative 3x, 8x, negative 1/3 x. All of these are like terms because they all have x as their variable. And there's actually no exponent on the x. What that really means is they all have an exponent of 1. So these are like terms, again, because they have the same variable and the same exponent. Another example of like terms, 6w squared, negative 12w squared, and w squared. All of those are like terms because they all have the same variable, which is w, and they all have the same exponent, which is that 2. So they all have w squared. All right, and what we're going to be doing when we combine like terms or collect like terms is we're going to be focusing on the number in front of the variable. That's called the coefficient, and we're going to be combining those by adding or subtracting. Something that we will see in an example like this with the w squared, if you don't see a number in front of the variable, assume that there's a 1 there. All right, over here in this blue box, here's some examples of terms that are not like terms. And so the title here is unlike terms. So the first example is 20x, x squared, and x to the 3rd. Even though those terms all have x, they have different exponents, so they are not alike. They cannot be combined together. Another example, 6xy, 2xyz, w squared. That one maybe is even a little bit more obvious. Each of those terms has different variables and different exponents. So those are some examples where you could not combine like terms. All right, let's do some actual examples of problems. So number 1 and 2 on here. The directions say simplify by combining like terms. And again, we can also use the word collecting like terms, same thing. So it's essentially kind of a matching game here. We're going to look at our expression and then figure out the terms that are alike. And remember, they have to have the same variable and the same exponents. So here's number 1, negative 4y plus 3x minus 6y plus 2. Okay, so I like to go left to right. Let's start with the negative 4y. I'm drawing a little box around it. You can circle it, you can highlight it, or you can just underline it or observe it. Let's see if there's any other terms in this expression that has the same variable and the same exponent. In this case, that variable would be y. So again, negative 4y plus 3x minus 6y plus 2. So the negative 4y, that can be kind of matched up or combined with the negative 6y. Negative 4 combined with negative 6, we're essentially adding those coefficients. So negative 4 plus negative 6, that becomes negative 10. Okay, or you could write it as negative 4 minus 6, still negative 10. So what that means is the next term that we write is negative 10y. We bring the y along. So we just combined negative 4y with negative 6y and got negative 10y. If you look at the other terms in the problem, we still have plus 3x, and then we have plus 2. Those have different variables that are different from y, and they're different from each other. 3x and then just 2 without an x, those can't be combined with each other. So we just get to copy them down. So our final answer for this problem will be negative 10y plus 3x plus 2. And that is it. Okay, so any other combining or collecting that you try to do would not work because now we have 3 terms that each have a different variable or no variable at all. I will say that you can write your answer in a different order. Remember in our last lesson before your test that you took recently in lesson 8, we talked about different properties. Remember the commutative property says we can switch the order when we add. So instead of writing the negative 10y first, I could have written the 3x first. If you like alphabetical order, you could write 3x and then minus 10y and then plus 2. That would be another way to write your answer. That would be correct. Okay, or you could put the 2 first. So there's different ways of rearranging it. Notice that the negative 10y still has that minus sign in front of it. Okay, it's either a negative sign or a minus sign, basically the same thing. So 2 ways of writing the answer: negative 10y plus 3x plus 2. Another way to write the answer: 3x minus 10y plus 2. There are other ways as well. Okay, so let's try another one. That was number 1. Let's look at number 2. This one has some decimals. 2.1x plus 2.5 minus 4.6x. Again, I'll go left to right. I'm circling the 2.1x, and I'm going to combine that with the minus 4.6x. They both have x, so they are like terms. Okay, so starting in this unit, you actually are allowed to use a calculator, so you're welcome to do that now if you want to use that to add your decimals. So 2.1 minus 4.6, that would be negative 2.5. If you don't have a calculator, here's how you'd write that out. The 2.1 is positive, the 4.6 is negative, but when I write this out as a subtraction problem, I would want to write 4.6 minus 2.1. I'm writing the bigger number on the top, so I can subtract in the correct order. I'm lining up the decimals. 6 minus 1 is 5. Bring down the decimal point. 4 minus 2 is 2. I'm getting 2.5, but because the bigger number is negative, I know my answer is negative. So it would become negative 2.5x. But again, if you use your calculator, then that's fine too. 2.1 minus 4.6, you'd get negative 2.5. You just need to know to bring the x down with it. And then the only other term left in the problem is just this plus 2.5. So I'll just copy that down. And that's it. So my final answer is negative 2.5x plus 2.5. Those are not like terms. Even though they both have a 2.5, that doesn't matter. What we need to look at is, do they have the same variables and the same exponents? They definitely do not have the same variables because the first term has an x and the second one does not. So we're done. All right. Now we'll get to some slightly harder examples. We're on the next slide now. This is number 3. This is a longer problem and it has more terms. 6x squared minus 19y squared plus 12x squared minus 4 minus y squared minus 5. All right, so I think that's 6 different terms that we have. So let's start collecting like terms or combining like terms. 6x squared. I'm looking along my list of terms and finding something else that also has x squared. So the next one that I see is plus 12x squared. When I circle these terms, I try to also circle, or I'm drawing a box here, I try to also include the sign to the left of the number. So in this case, I did include that plus sign. That will become even more important when you're dealing with negatives or minus signs. That will need to stay with the number that it's next to. Okay, so 6x squared plus 12x squared, those are the only x squared terms, so I'll just go ahead and combine those now. 6 plus 12 is 18, so I'm going to write 18x squared. Now I'm going to keep going and looking at my list of terms. I'm going to use a different color just to kind of stay organized here. So the next term is minus 19y squared. So I'm going to look along my expression here and find another term that has y squared. So the next one that I see is just this minus y squared. So I will circle that. So I've circled minus 19y squared and then just minus y squared. I'm going to put a 1 in front of that y squared. So when you combine these, think of it as negative 19 plus negative 1, or negative 19 minus 1. Same thing. You get negative 20. Both of those numbers are negative, so I will add and keep the negative sign. So I'm getting negative 20. So what that means is my next term is minus 20y squared. So notice how I'm adding or combining the coefficients. The coefficients are just the numbers in front of the variables. I'm combining those. The variable stays the same along with its exponent. So the y squared is just the same the whole way through. In other words, don't add the exponents in case you were considering doing that. Don't do that. Keep the variables the same, keep the letters the same. The only thing you're changing is the coefficient, meaning the big numbers in front of the variable. So far we've done 6x squared plus 12x squared is 18x squared. Then we did negative 19y squared minus 1y squared is minus 20y squared. And the last two terms that I haven't circled, those are both called constant terms. They're just numbers, no variables. So it's minus 4 and minus 5. Those are both negative. So when I add them, I will add and keep the negative sign. So negative 4 plus negative 5 is negative 9. So I'm writing minus 9. So my final answer for this problem is 18x squared minus 20y squared minus 9. And I could rearrange those three terms if I wanted to. There's no one best way to do it. I'm just going to leave them in this order though. So if I wrote it in a different order, that would be fine, as long as each variable kind of had its same coefficient. So once again, 18x squared minus 20y squared minus 9 would be my final answer. All right, next problem, number 4. 4/5 x minus 3/7 y minus 9/4 x plus 1/7 y. So that's 4 different terms with 4 different fractions. However, we will not be adding all of the fractions together. We'll just be adding the ones that are like terms. So I'm paying attention to the variables. 4/5 x is the first one that I will circle. And let's find another term that also has the same variable. So the next term I see with an x is this minus 9/4 x. Okay, so what I've kind of circled or boxed off here is 4/5 x and minus 9/4 x. So I need to combine these fractions together. Okay, so I'm adding 4/5 with negative 9/4. Or I'm just writing it as a subtraction problem. So 4/5 minus 9/4. I need a common denominator. Between 5 and 4, I can just multiply together and get 20. So my common denominator can be 20. Okay, so we've done this before. We're getting common denominators. 4 times 5 is 20. So I'm going to multiply in my first fraction, 4/5. I'm doing 5 times 4 to get 20 for my denominator. So if I'm multiplying by 4, in the denominator, I also need to multiply by 4 in the numerator. This is essentially multiplying by 4 over 4, which is just a form of 1, and that's why we're allowed to do that. So that's 16 for my numerator. So 4/5 is now changed to 16/20. Okay, now moving to the next fraction, minus 9/4. This time that 4 in the denominator is getting multiplied by 5. 4 times 5 is 20. And then the 9 in the numerator also gets multiplied by 5. So once again, I'm multiplying by a form of 1. This time it's 5 over 5. So 4 times 5 is 20. 9 times 5 is 45. So I've rewritten these fractions as 16/20 minus 45/20. So now I need to subtract. Let's see. I'm going to subtract 45 minus 16. 45 minus 16. And I'm getting 29, but the bigger number is really the one being subtracted, so this is becoming negative. So this fraction ends up being negative 29 over 20. And by now I've almost forgotten that there was an x here the whole time. So really all of that work was just to get the first half of my answer, which is negative 29/20 x. Okay, now we have to do a similar process with the y variables, with the y terms. This one will be easier because they already have a common denominator. So the other terms we haven't combined yet are negative 3/7 y plus 1/7 y. So when I combine those fractions, negative 3/7 plus 1/7. They already have a common denominator of 7. So I don't need to do that extra work of getting a common denominator. It's already there. So I'll just add the numerators. Negative 3 plus 1, because the signs are different, I'm subtracting and keeping the sign of the bigger number. The bigger number is 3, which is negative. So negative 3 plus 1 is negative 2. So I'm getting negative 3/7 plus 1/7 is negative 2/7. Putting that all together, basically putting the y in the answer, that term now becomes negative 2/7 y. Okay, so my final answer for that problem is negative 29/20 x minus 2/7 y. Notice how I'm writing the variables kind of next to the fractions. So just be careful as you're typing these answers. You can put the variables in the numerator, but I would recommend just typing the fraction, then kind of using your arrow key, and then putting the variable just to the right of the fraction. Fractions should always be reduced, but there is no need to change an improper fraction to a mixed number. In fact, I would not recommend doing that, and you might even get it wrong if you do. So now that we're kind of in this algebra portion of this course, where you're actually seeing variables, we do actually prefer to keep fractions written as fractions. Once you start writing them as mixed numbers with a variable next to it, it looks a little awkward, and we basically just don't do it. So I'm going to leave the fractions as they are. Negative 29/20 x minus 2/7 y. Okay, so in other words, the 29/20, even though it's improper, I'm good with that. Leave it. Don't change it to a mixed number. All right, so I feel like for that problem, the easier part is just matching up, oh, the x's go together and the y's go together. That's probably not the biggest challenge. The biggest challenge is probably still the fractions. So just be aware of that. All the way back to lesson 1 when we learned about fraction operations. So just keep those things fresh in your mind. We're going to continue to practice. We'll still need to add and subtract fractions and get common denominators. So if you feel like you're not quite there yet with feeling totally comfortable and like you've totally mastered fractions, the good news is that you'll continue to get practice here. All right, moving on. Now that we have seen some examples with collecting like terms, we're going to do some quick review of the distributive property, which is something we saw in lesson 8. So now we'll see some parentheses. Once we review the distributive property, we're going to put those things all together. We will see longer problems where we have to distribute and then also collect like terms. We'll have to do both. All right, so let's look at our first 2 examples. So a reminder about the distributive property. It looks like this: A parentheses B plus C can be written as AB plus AC. In other words, when there's a number outside of parentheses, like A, you distribute it, you multiply it by each term inside the parentheses. So here's an example with a number, 3 parentheses x plus 5. That's equal to 3 times x plus 3 times 5. And when we simplify that, that's 3x plus 15, because 3 times 5 is 15. So let's do a couple examples using the distributive property. This is review. Here's number 1. 3 parentheses x plus 9. So I'm going to draw some arrows, as I am used to doing, to show the distributive property. And I'll just do that quickly up above as well. All right, so 3 times x plus 3 times 9. And then, of course, we need to simplify. 3 times x, I've written 3 and then a little dot and then an x, but we just write 3x for our answer, plus 3 times 9 is now 27. So my final answer is 3x plus 27. And I cannot combine those because now we know about like terms. These are not alike. The 3x has an x and the 27 does not. So back to the previous example, the one with 3 parentheses x plus 5. Remember how that was 3x plus 15? I wrote a little note over here. That's not 18x. Okay, so in case you were wondering, do I add the 3 and the 15? No, definitely not. Okay, so just keep those terms separated. All right, number 2. This time we're distributing a negative and we're distributing a fraction. So we have negative 1/2, parentheses, 8x minus 14. So let's distribute that negative 1/2. Okay, so we're multiplying negative 1/2 times 8x, and then we're multiplying negative 1/2 times negative 14. So each of those will obviously need to get simplified. So negative 1/2 times 8x, and then negative 1/2 times negative 14. Okay, first, when you're distributing a negative, prepare for your signs to be changed in your answer. So that 8x was positive, but this term that it's about to change into will now be negative. That minus 14, because it's being multiplied by a negative, that's about to turn positive. So get ready for your signs to change. And here's a reminder about multiplying with fractions. You get to just multiply straight across. No common denominator is needed. So what I'm doing right now is putting the 8x over 1 and the 14 over 1, just to remind you about numerators and denominators. Negative 1/2 times 8 over 1. I can actually reduce the 8 with the 2. 8 divided by 2 is 4. This kind of looks like negative 1 times 4x over 1. If I just multiply straight across now, negative 1 times 4x is just negative 4x. And then my denominator would just be 1, which means I don't need to write it at all. So don't write negative 4x over 1, just write negative 4x. It makes sense because half of 8 is 4, right? So negative 1/2 times 8x is now negative 4x. Moving on to the second term, negative times negative is positive, so I'll write a plus sign. 1/2 times 14 over 1, just like the previous term, I can reduce because 14 divided by 2 is 7. This just becomes plus 7. Half of 14 is 7. Okay, I mean it's 7 over 1, but we just write 7 in our final answer. So the full final answer here is negative 4x plus 7. So on your homework, when you see problems where you're distributing a fraction, more often than not, probably not always, but more often than not, your answer will simplify. So you won't necessarily be writing fractions in your final answer. Now, if the fractions didn't simplify, that would be okay, right? If this was 1/3 instead of 1/2, then I would just have fractions in my answer and that would be fine. You might have negative 8/3 x plus 14/3. That's okay, that can happen. All right, good. So we've seen some distributive property review problems just now. We'll move on. Oh, there's one more that I almost missed. Sorry, number 3. Just right there at the bottom. Then we'll move on. All right, number 3. What we have here is a negative sign and then parentheses. And then the parentheses is negative 8x plus 9y minus 5. Okay, so essentially we're distributing just a negative sign. Treat it like a negative 1. So I'm just writing a little 1 right next to the parentheses. And that's what we will be distributing. Every term will get multiplied by negative 1, which means we're simply just changing the signs. Negative 1 times negative 8 is positive 8. So this first term, negative 1 times negative 8x becomes positive 8x. On to the second term. Negative 1 times 9y is now negative 9y. On to the third term. Negative 1 times negative 5 is positive 5. Okay, so that was another reminder about negatives. Okay, so when you distribute a negative, each of your terms will have their signs changed. for your final answer. All right, now we can move on. So now on to the next set of problems. We will be distributing, but we will also be combining like terms or collecting like terms. So this is now the simplifying expressions part of this lesson. Okay, so now we're putting it all together. You can see the instructions. Distribute first. That's what we were just reviewing. Then combine like terms. That's what we learned earlier, or collect like terms is another way to say that. Okay, so anywhere you see parentheses, if there's a number in front of the parentheses, we will start by distributing that. So let's start with this -5. Here's the full problem. -5, parentheses, x minus 4, close parentheses, minus 3, parentheses, x plus 2, close parentheses, plus 1. Okay, so back to the beginning, -5, then there's parentheses. We're about to distribute the -5 into x minus 4. So -5 times x is -5x. -5 times -4 is positive 20. So what I've written so far is -5x plus 20. Next, we're going to distribute this -3. Okay, so it looks, you might read it as -3, which yes, that is what it is. But because there's parentheses immediately following that 3, we know we need to distribute or multiply not just a 3, but treat it like a -3. Okay, so -3. And then in parentheses, x plus 2. So -3 times x is just -3x or minus 3x. -3 times 2 is -6. So I'm writing -6. You could write plus -6, but I'm just writing -6, same thing. And then finally, there's this plus 1. Now, that was not in parentheses, so nothing gets distributed towards that plus 1. We're just copying it down. So here's what we have written so far. -5x plus 20 minus 3x minus 6 plus 1. So we did the distributing part. And now we're about to do the combine like terms part of the problem. So we distributed. And now combine like terms. Okay, so combining like terms, that's where we're looking for the terms that have the same variables or the same exponents, but we don't have any exponents here. So -5x will be combined with -3x. -5 plus -3 is -8. So we will write -8x. Okay. Now, all the other terms are constant terms, meaning none of them have variables. So I can kind of combine them all at once. 20 minus 6 plus 1. Okay, so 20 minus 6, that would be 14. 14 plus 1 would be 15. So I'm going to write plus 15. So my final answer is -8x plus 15. Now, if you wanted to break that down a little bit more, maybe you would write -8x, and then you'd write plus 14 plus 1, and then combine 14 plus 1 into 15. So you could slow down and break it down more. But the point is, we distributed. When we saw parentheses, we distributed the numbers that were to the left of the parentheses. After that, then we combine like terms. So we combined the terms that had x's together. -5x minus 3x became -8x. And then we also combined all the numbers, also known as constant terms. All right, so our final answer is -8x plus 15. So that is what we mean by simplifying expressions. This entire problem was called an algebraic expression. It's simplified when there's no more parentheses and all the like terms have been combined. That was number 1. Let's take a look at number 2. This one has multiple layers of grouping symbols. There's parentheses as well as brackets, which means there's going to be multiple layers of distributing. Okay, so here's the original problem. 9p minus, then we have square brackets, 5 minus 8, then parentheses, 5p minus 2, close the parentheses, and then also close the brackets. Okay, so remember with order of operations, how we kind of worked from the inside out when we're dealing with grouping symbols like parentheses. It's the same idea with distributing. So I'm going to work from the inside out. So the inner parentheses, 5p minus 2, there's nothing to do in there, but I'm looking at this number right outside those parentheses, this minus 8. So I'm about to distribute, kind of in the middle of the problem here, this minus 8 will be distributed into the 5p minus 2. So I know I said minus 8, but it's also a negative 8, same thing. Negative 8 times 5p, that's negative 40p. Negative 8 times negative 2, that's now positive 16. Okay, since I distributed through those parentheses, I no longer need the parentheses. But there are still some other numbers and some square brackets, kind of as that next layer of grouping symbols. So as I copy down everything else, I'll do it really carefully. We still have 9p minus, square bracket, 5. And then right after the 5, we still have that minus 40p plus 16 that we just did. Then I will close up the square brackets. Okay, speaking of square brackets, we can simplify here, right? So usually after we distribute, come on. Sorry about that. After we distribute, we then get to combine. So we're kind of doing this twice here. So we distributed with parentheses, then we combined. Now we're going to, oh, no, sorry. Now we're going to combine. Sorry about that. So what are we going to combine? Let's take a look inside these square brackets. 5 minus 40p plus 16. Okay, so what we can combine, the like terms are 5 and 16. 5 plus 16 is 21. Okay, so when I rewrite what's in these square brackets, I'm going to just write minus 40p and then plus 21 because I combined the 5 plus 16 to make positive 21. Okay, so see how it kind of still feels like an order of operations problem, those longer problems where you're copying things down multiple times. So here's where we are, 9p minus, oops, I forgot something. I said it, but I didn't copy it down. So I forgot to write the p next to the 40. Okay, here we are, checking again, 9p minus, square bracket, negative 40p plus 21, close the square bracket. All right, at this point, the square brackets are just like parentheses. They're just grouping symbols. There's nothing else I can do inside them. I already combined. So now I will distribute again. So it's kind of like round 2, distribute again. But this time, what we're distributing is right outside the square brackets. It's this minus sign. So when we distribute a minus sign, really it's like we're distributing a -1 or a -1. So that's what I'm distributing next. So this -1 now gets multiplied into the square brackets. So it's -1 times negative 40p, which is positive 40p. -1 times 21 is negative 21. No more square brackets. We're almost done. All that's left to bring down now is that 9p. I have done nothing with that yet. Okay, remember before how we distributed and then we combined? Then we distributed again. Now we get to combine again. Meaning it's another round of combining like terms. So what are the like terms? Well, I have 9p plus 40p minus 21. So it's the 9p plus 40p that we can now combine together. 9 plus 40 is 49. So finally, I'm ready for my final answer, 49p minus 21. Okay. Obviously, that was a much longer one. We kind of had to go through those processes multiple times. We use the distributive property kind of from the inside out, meaning if there's multiple layers of parentheses or grouping symbols, start kind of at the innermost grouping symbols. In this case, it was the parentheses. We distributed that -8. Then we combined the 5 plus 16 and got 21. Then we distributed again. This time it was distributing that minus sign. treating it like a -1. And then we got to combine like terms again. The order there is pretty important. If you try to distribute the minus sign, you get a little mixed up because you hit this extra layer of parentheses and you might wonder what to do there. So I'm going to say stick with this order, working from the inside out as you're working through distributing and then combining and then distributing and then combining. And by the time you're done, there's no more grouping symbols, no more parentheses or brackets. All right, that was number 2. Okay, we have 3 and 4 to go. All right, number 3. Let's see, this one looks maybe not as long. Let's see, -9c minus parentheses, -2d plus 8 in parentheses, close the parentheses, sorry, plus parentheses, 13c minus 7, close parentheses. So there's 2 different sets of parentheses here, but they're not contained inside each other. So there's 2 different places where we might distribute. Let's just work left to right this time. So -9c minus parentheses. Okay, so that minus sign in front of the parentheses, treat it like a -1. Let's distribute that -1. So -1 times -2d is positive 2d. -1 times 8 is -8. I'm going to bring down that -9c that came before. Okay, and moving along in the problem, I have plus parentheses 13c minus 7. Okay, so now we're kind of hitting up against this other parentheses. Okay, we don't really need those parentheses there at all because there's really nothing in front of the parentheses other than a plus sign. So if I were to distribute something, it's really just a +1. So I'm drawing this arrow here, +1 times 13c and then +1 times -7. When you multiply something by +1, it stays exactly the same. So essentially, I'm just copying those terms down. Nothing is changing here. 1 times 13c is just 13c. 1 times -7 is still -7. Okay, so at this point, there's no more parentheses. In the first parentheses, I distributed that minus sign kind of as a -1. The second parentheses, I distributed a +1. So here's where we are. -9c plus 2d minus 8 plus 13c minus 7. Now let's see if we can combine like terms. So we distributed first. Now we combine like terms. Let's start with the -9c. Can we combine that with anything? Not with the 2d. Those are different letters. Not with the -8. Oh, over here with the plus 13c. Those terms both have the same letter. -9c plus 13c. So -9 plus 13. Those numbers have different signs, so we will subtract and keep the sign of the bigger number. 13 minus 9 is +4. And I'll keep the sign of the 13, which is positive. So I'm getting +4c when I combine those terms together. So 4c. All right, next term that I notice is this plus 2d. But there's no other terms that have that letter D. So I just get to bring that straight down, plus 2D, which leaves us with the constant term. So we have this -8 and -7. -8, -7. Okay, so that's the same thing as -8 plus -7. They have the same sign, so we add 8 plus 7 is 15 and keep the sign of, keep the common sign, sorry. They're both negative, so I keep the negative sign, it becomes -15. So I'm writing -15. So I have 3 terms in our final answer. 4c plus 2d minus 15. And that's our final answer. So in this problem, we did distribute and then we combined like terms. We kind of did it multiple times, sort of in the same steps, because we had 2 different sets of parentheses, but they weren't contained inside each other. So we were able to kind of work left to right. All right. One more problem to do. Here's another one that has multiple sets of parentheses and square brackets. So this is another work from the inside out type of problem. here we go. So it's square brackets, 5, parentheses, x plus 3, close parentheses, minus 5. Close the square brackets. That right there is kind of its own problem. So we're going to work on that. Then plus square bracket, 4 parentheses, x minus 1, close parentheses, plus 12, close the square bracket. All right, so we're going to work from the inside out, but there's kind of two different insides, I guess. So both of the places where you see just those sort of round parentheses, let's work on both of those first. Let's start with the 5. So there's inside the square brackets, there's 5 parentheses x plus 3. So I will distribute the 5. That will become 5 times x, which is 5x, plus 5 times 3, 15. Okay, I'm now going to copy down the square bracket that was there in front of the 5x. There's also this minus 5 that's still inside the square bracket. Okay, so what I've written so far is square bracket, 5x plus 15 minus 5, close square bracket. Now, there's this plus sign, and then there's a new square bracket. So what's happening inside of there? Well, there's a 4, and then there's parentheses, x minus 1. So let's distribute that 4. 4 times x is 4x. 4 times negative 1 is negative 4. So I'm writing 4x minus 4. Then there's also plus 12. Close the square bracket. So we have 5x plus 15 minus 5, that's all in one square bracket, plus square bracket, 4x minus 4 plus 12, close square bracket. Okay, let's see if we can simplify inside each of those grouping symbols. So in each of them, there are like terms that we can combine. So for the first one, 5x plus 15 minus 5, it's the plus 15 minus 5 that are like terms. 15 minus 5 is positive 10. So I will combine those into just plus 10. So when I copy down what I still have in the square brackets, 5x, and then just plus 10, close square brackets. Plus. Let's do something similar in our second set of grouping symbols over here. So 4x minus 4 plus 12. This time it's the minus 4 plus 12 that we can combine. Negative 4 plus 12 we'll subtract because the signs are different. 12 minus 4 is 8. Keep the sign of the bigger number. This is positive 8. So I'll write plus 8. And coming right before it was 4x. So here's what we have so far. Square brackets, 5x plus 10, close square brackets, plus new square brackets, 4x plus 8, close square brackets. At this point, we don't really need the square brackets at all. There's nothing in front of them. There's nothing to distribute into them other than just positive 1. So you could kind of treat it like you're distributing a positive 1, I guess. So I'll just write a little 1 in front of those square brackets, distribute it. That might seem unnecessary to you, that's fine. Basically, you can just copy everything else down without the square brackets. So one more time, 5x plus 10 plus 4x plus 8. Because when I distribute a 1, everything just stays exactly the same. 1 times 5x is 5x, 1 times 10 is 10, 1 times 4x is 4x, 1 times 8 is 8. Are we done yet? Almost. Here we go. So combine like terms one last time. No more parentheses, no more square brackets. We're about to be done. So 5x plus 10 plus 4x plus 8. The x's are like terms. 5x plus 4x is 9x. And then the constant terms, just the numbers, those are also like terms. Positive 10 plus 8, that's positive 18. So I'm writing plus 18. So after all that, my final answer is 9x plus 18. All right, so now it should really feel like you're in an algebra class. If it didn't feel like that before, now you know. So that was a pretty big introduction using a lot of variables. Where we're going from here, lessons 10 and 11 coming up, we're going to be doing a lot of solving equations. That's coming up next, but we will still definitely need all of what we just did. So the distributive property, still, we're going to see that in a lot of different places, and then collecting or combining like terms. Those will both be kind of foundational skills for what comes next. All right, so we've made it to the end of lesson 9, and I will see everybody soon.